What's up, guys? It's Mr. Brengle, and today we're going to be talking about the wizard level of the series circuit V equals IR calculations concept builder from physicsclassroom.com. In a previous video, I went over the master level, so if you need to do that one, check that video out first. And in this video, we're going to be talking about the wizard level, which is a little bit different. But if you do this one, you should be able to figure out the master level as well. Okay, so just to talk about what's different between this one and the master level, it has given us basically the same columns here: battery voltage, first resistor, second resistor, total resistance. Remember, REQ stands for equivalent resistance, which is the same thing as the total resistance. Then it's asking us for the current at point A, the current at point C. It's actually asking us for the potential or the battery or the voltage at point B. So if you'll kind of follow me here, what's happening is electrons are moving this way through point A. They go through the first resistor. They're going to experience, there's going to be a voltage drop at the first resistor. So really what point B, or the voltage at point B, is asking for is how much voltage is left over after the voltage drop at R1. And another way to say that is, what is the voltage drop at R2? So we are going to be solving for the voltage drop of the second resistor. That's what's going to go into this column here. So let's do some of this here together. Now, similar to the master level, to solve here for the total resistance is usually going to be our first step. And in a series circuit, that is accomplished by adding all of the resistors together. In this case, we're going to add 4 and 8 together. We're going to get a total of 12 ohms of resistance. Then we need to solve for the total current in the circuit, which will be the same as the current everywhere. So it doesn't matter what point you look at on this circuit, the current's going to be the same. And we're going to use the equation current is equal to voltage divided by resistance. I'm just going to put these other equations on here to start with. Resistance is equal to voltage divided by current. Same equation, just different configuration. And then voltage is equal to current times resistance. So Ohm's law equations there. So to solve for our total current in the circuit, we're going to take the battery voltage, 24 volts, divide it by the total resistance of 12 ohms. So we're going to get a current of 2 amps everywhere in the circuit. So we'll fill that in for points A and point C. Now it is asking us to solve for the voltage that's left over at point B after the voltage drop at R1. To do that, we can just solve for the voltage drop at R2, because the rest of the voltage will be dropped at R2. Now, to solve for voltage, we're going to multiply current and resistance together. So the current is the same everywhere in the circuit, it's 2. And then we're going to multiply it by the resistor 2, because the voltage drop at R2 will be dependent on R2's resistance. So 2 times 8 is 16. That is how much voltage is dropped at the second resistor. You'll notice that there's a total of 24 volts, so we can assume that 8 volts has been dropped at R1, but you can double check this by multiplying current times R1. 2 times 4 is 8, so it checks out. So that's kind of how we'll go through these. Now, on this second one here, you've got a total resistance of 16 ohms. The first resistor is 8 ohms, so that means the second resistor must also be 8 ohms. Now, I can tell you right now that the voltage drop at R1 and R2 is going to be 12 volts. I know that because the battery voltage is 24 volts, and they both have the same resistance. The current is obviously the same everywhere, so that means that you're going to have to drop half of the voltage at each of these resistors here. So we'll go ahead and do the calculations, but we know that this is going to be 12 here. So let's go ahead and solve for the total current in the circuit, and then we'll see if that calculation works out. So to find total current, we're going to use this equation right here: total voltage, 24 volts, divided by the total resistance here of 16. So 24 divided by 16 should be 1.5, which it is. And we'll go ahead and plug this in here for the current everywhere. Now, if we go back and calculate our voltage drop, it's current times the second resistor. So 8 times 1.5, which is 12. So it does check out there. All right, now moving on to our next one here. It has given us the current at point A, so I know that the current at point C is also 2. We can actually use this current to solve for our total resistance now. So resistance is voltage divided by current. We have the total voltage, we have the total current. So 24 divided by 2 is going to give us 12 ohms of total resistance. And then that means that our second resistor must be 6 ohms since the first one is 6. And then once again, since these two resistors are identical, you're going to have identical voltage drops at each resistor. Since the total is 24 volts, that means we'll drop 12 volts at each. Again, to show you the calculation, you multiply current times the individual resistor. So 2 times 6 is 12. And then again, 2 amps times the other resistor, 6 ohms would also be 12 volts dropped. So anyway, moving on here, it's given us the current at point C, so I'll go ahead and put in the current at point A as the same thing there, 0.5 amps. And then we will calculate our total resistance by using total voltage divided by total current. So 24 volts divided by 0.5 amps. And that is going to give us a total of 48 ohms of resistance. That means that since 16 ohms are in the first resistor, the second resistor is going to have to be 32 ohms of resistance. And now we can calculate the voltage drop. The voltage drop is current times the second resistor. So 32 times 0.5 is going to be a voltage drop of 16 volts. If we just want to double check to make sure that it adds up to 24, we can do the voltage drop at the first resistor, which would be 0.5 times 16, which is 8. 8 plus 16 is 24, so it checks out. Moving on to our final two here. It's given me the current at point A, so I can go ahead and put in the current at point C. It's going to be identical. Now it's given me the voltage drop at point B, or the second resistor, so I could use that and the current to solve for resistor 2. Let's go ahead and solve for the total resistance, though. We'll do that. Total resistance is voltage, total battery voltage divided by the total current. So we're going to take 36 volts divided by 2 amps, and that's going to give us a resistance of 18 ohms, total resistance of 18 ohms. Okay. And now we can look at the R2 here, this resistor. Since we know that the resistor drops 12 volts right here, and we know that there's 2 amps of current going through it, we can again use this equation, 12 volts dropped at that particular resistor and 2 amps going through that resistor. So 12 divided by 2 is 6. So I know that we have 6 ohms of resistance at R2, which means we must have 12 ohms of resistance at R1. Again, if I kind of forgot to bring this up at the beginning of the video, we're on the last one here before I'm bringing it up, but if at any point you're not sure if you got an answer correct, you can just click check answers, and it's going to tell you, it's going to give you a green mark if they are correct and a red mark if it's incorrect. It will subtract from an overall health bar if you get questions wrong. So if you continue to do that and you're just guessing, your health bar will be depleted and you'll have to start over. So this is just more meant for you to check your work and make sure that you're doing things correctly. All right, now we can move on to the last one here. And the last one is a little bit tricky because it doesn't give us the current anywhere, and then it only gives us one of the resistors. It does give us the voltage drop at R2, though. The reason why it's tricky is because you need the voltage drop at R1 to be able to solve for the next thing. So what we're going to do here is we know there's a total of 48 volts. 36 of them are dropped at R2. That means that 12 volts are dropped at R1. Okay, this is important because we have the resistance at R1. So we can take the voltage at R1, the voltage drop, the resistance at R1, and use that to calculate how much current was going through that particular resistor. So we're going to use this equation right here. Current is equal to the voltage drop at R1, which is 12, divided by the resistance at R1, which is 6. So I know that I'm going to end up with 2 amps of current going through that resistor, which is the same everywhere in the circuit. Okay. So again, to figure that out, what I did is I took the total battery voltage minus the voltage drop at R2, and that tells me that 12 volts were dropped at R1. Since I have that resistor, we can use this equation here. 12 volts dropped at R1 divided by 6 ohms of resistance at R1, and that gives us 2 amps of current. Now I can go and I can solve for things the way that we have been doing. If we want the total resistance, we can take total voltage of 48 divided by total current of 2, and that's going to give us 24 total ohms here. And then I know that my other resistor must be 18 ohms to match up. Alternatively, you could solve for the second resistor here by doing the voltage drop at R2, which is 36, divided by the current, which is 2. 36 divided by 2 is 18. Then you could add these two together to get your total resistance here. Okay, so we'll go ahead and check our answers. Yay, finished it. So that right there is the wizard level of the series circuits V equals IR calculations. Again, the master level was done in a different video, so make sure to check that out if you need to. And make sure to let me know if you have any questions.